Dear scientists and participants, welcome to our first International Symposium, IGRS, International Graduate Research Symposium. During 3 days, you will share and discuss the most up-to-date studies in numerous fields. We hope that you will not only enjoy this symposium, but also you can follow the new developments in different disciplines. Let me introduce you to the Dean of Graduate School, Professor Dr. Ahmet Duran Şahin, for his opening speech. Welcome, Professor.
Thank you, Merve. Dear Vice Rector of Istanbul Technical University, dear researchers, and good morning to everybody. First of all, I want to say welcome to International Graduate Symposium 2022. This symposium is an interdisciplinary and multidisciplinary event, and it is the first organized by the Graduate School of Istanbul Technical University. Despite the first symposium, over 400 manuscripts have been loaded to the system and got chance to be in the program. In my opinion, a new tradition has been started in ITU. As known that Istanbul Technical University, which is approaching its 215th anniversary, is one of the oldest technical universities in the world and first technical university in Turkey. Is identified with its engineering and architectural education. When we consider graduate education also, ITU is one of the leader universities in Turkey. In graduate school of ITU we have 76 departments. In these departments, we have 98 master program with thesis, 24 master program with non-thesis, and annually I can announce that 71 doctorate programs we have. Really, it's a great amount for graduation education in Istanbul Technical University and in Turkey also. When we look at our students, totally we have 10,443 students and 3,566 are doctorate students, 6,877 are master students. If you want to make a comparison between Istanbul Technical University and other technical universities in Turkey, we are the first rank for graduation education. It depends on the students, the number of students. Okay. Organizing International Graduate Symposium has been started approximately 10 months ago. And it was really very hard for us to manage process related with this event. One of the main problems is to connect and collect different disciplinaries at one symposium. However, one of the main advantages of this multidisciplinary approach is to understanding scientific approaches at different perspectives. I hope researchers at different disciplinaries would understand to each other by high-level scientific discussion and sharing experiences with information. Next year, we have some plans. I hope we may get this symposium great. We want to organize IGRS 23 as a big event in a part of graduate days that include promotion days, fairs, and exhibitions related with graduate studies and social activities, hope face-to-face. We want to set a target as the biggest and effective graduation days in Turkey next year. During this symposium, firstly, I want to thank the Vice Dean of Graduate School, Dr. Ahmet Öztopal, for his great effort and devotion to the IGRS 22, and hope this effort will continue in IGRS 23. During this symposium, Additionally, I want to thank the Vice Dean Dr. Burak Bulga, Dr. Burcu Yıldız Ataş, and Dr. Abdülsamet Subaşı for their support and efforts of organizing RGRS 22. I want to thank the keynote speakers, Dr. İbrahim Dinçer, Dr. Zeki Ayşen, Dr. Yusuf Yağcı, Dr. Liza Cilman, and Dr. Fatma Gül Bektay to accept our invitation. Also, I want to thank all participants for their valuable contributions to the symposium. And I want to thank the chairs of each session to accept our invitation, and I know that they will manage each session with their great efforts. Especially, I want to thank the research assistant of Graduate School of ITU. They are our heroes for all stages of IGRS 22. Thanks to Aycan Kızılkaya, Bayram Arslanoğlu, Berker Pandır, Erdem Çiçek, Gökhan Güler, Güncel Gürsel Artıkoğlu, Hande Vural, Hatice Şeyma Selbesoğlu, Melek Akın, Merve Ağaoğlu, Sena Karakaya, Sıla Burcu Başarır. Really, they shows great efforts, and thank to all of them. I hope to continue with this great team in the next International Graduate Research Symposium and graduation days. I hope high-level scientific discussion and information shares will be during this symposium. If you face with any problems, please contact with me or any member of the IGRS team. We will try to solve the problem as soon as possible. Thanks to all participants and my colleagues. Thank you.
Thank you, dear Professor. And now, here is the Vice Rector of Istanbul Technical University, Professor Dr. Lütfiye Durak Ata, for her opening speech. Welcome, Professor.
Okay, thank you very much. Dear academicians, dear graduate students and researchers, I'm very pleased to address you at this very special opening moment. This is the first International Graduate Research Symposium organized by the Graduate School of Istanbul Technical University. This is a great opportunity for all of the graduate students to share their great work that they have performed during their master's and PhD studies. And also, we will have the opportunity to listen to inspiring keynote speeches. I followed the effort of the graduate school closely for this symposium from the beginning, and I'd like to congratulate all of the organizing team and the technical committee. Thank you very much. As you know, Istanbul Technical University is heading towards 250 years in education in 2023, and this is our 249th year. And Istanbul Technical University owes its success to high-level research, successful education, and continuous innovation. We have been pioneering in many fields of engineering and architecture research in Turkey and also abroad. And we will continue working hard to advance our success to further levels. I can say that our vision is to create a culture of responsibility by integrating the values of sustainability in all units of Istanbul Technical University. And we want to serve as a local and a global model. Also, the Sustainable Development Goals shows us a path to protect the natural environment, human and ecological health, while promoting innovation. And we do not want to compromise our also future generations' lives. So we make a strong commitment to scientific and technological advancement, to further levels of collaborating with many peer institutions on the global scale, according to these Sustainable Development Goals. And as Istanbul Technical University, we enhance our efforts through a European University initiative. And we would like to give a European engineer degree to our students. This European University is named as ELISA. It's the acronym of our alliance. It's European Engineering, Learning, Innovation, and Science Alliance. Being one of the world's oldest universities in the field of engineering education, we now try to redefine the European engineer model and engineering education within the framework of ELISA European University Initiative, with active participation of our strong academic staff and also hardworking graduate students. I'd like to say that we envision a future where academic excellence and innovation are always linked to social responsibility and commitment. We want to design a future where academic and non-academic partners come together to solve real-world problems, to introduce solutions, to create new solutions to real-world challenges. And we give importance to gender balance in STEM careers, cooperation among researchers, students, and civil society, being a responsible member of higher education era. And I believe that we can reach these goals by joint efforts of all researchers, the graduate students, and academicians together. I'd like to thank you very much once again to all of you, the organizing community, for contributing to this very well organized symposium. I will be following the symposium in the following days. And thank you very much, Professor Ahmet Duran Şahin and the organizing team. I'm very curious about the future symposiums. I will be waiting. I will be looking after them. Thank you very much.
Thank you, dear Professor. Our symposium, we will also share some musical performances with you. These performances are all produced by ITU MIAM, the Center for Advanced Studies in Music. The first piece is played by Yelda Özgen and Jarfi Aji and composed by Ernest Bloch, Prayer No. 1. Please enjoy this gorgeous performance. Hello again. Now I am presenting our first keynote speaker, Professor Dr. Ibrahim Dinçer from Ontario Tech University. His research areas are thermal energy, sustainable and renewable energy technologies, new energy storage methods, advanced cooling technologies, alternative energy strategies, and policies. He is the editor-in-chief of important international journals, such as International Journal of Energy Research, and is also a member of the editorial board of more than 30 technical journals. The title of his speech is Clean Energy Solutions and Their Management for Better Sustainability. Welcome, dear Professor.
Thank you. Good morning, everyone. I am really delighted to be here today, really connected, and to make a presentation on clean energy technologies and their management. So let me start sharing my screen, and presumably these are now fine. So are you able to see all nicely?
Yeah,
Hello?
we can, Professor.
Excellent, excellent. So again, good morning, everyone. And really, it is a great honor for me to make this presentation in such a nice conference with the young audience, and of course, joining this event as their really annual event. Anyway, so now since the topic is really about energy, but before doing so, let's look at the global challenges. And if you put the pandemic aside and try to rank the rest, and you see always energy is coming really either the first or second or third, but no matter whatever ranking scheme you consider, you see energy always making the top. So, and now let's get into, and I have a clean energy research laboratory, and really I have been leading various projects in really some key areas. And some quick examples: hydrogen and fuel cell technologies, renewable energy technologies, energy storage technologies, hybrid and integrated energy systems, electric and hybrid electric vehicles, alternative fuels and production technologies. Really, in a nutshell, these are my some key research domains. Innovation is very critical in my research, and I always introduce innovation by these 5 dimensions. These are very critical, and really each with a P. And look at this, very first, people. Everything starts with people, and people make difference. And then, of course, is it really sufficient to have people? No, we need to go beyond. And really, we need passionate people. So the passion comes next. And then, of course, anything else really required to establish partnerships. So to work together, develop partnerships. Next, really coming down to policies, to be able to really develop right policies, and then also, of course, processes coming into the picture. So making sure that those are implemented accordingly. So these 5 Ps really make the key dimensions of innovation. Additionally, one important thing, Rick, research, innovation, and commercialization. especially in a graduate conference like this. This has to be a critical item in it. Why? Because we want to convert or turn knowledge into technological products, something tangible. This doesn't mean that we don't publish. This doesn't mean that, we are not going to disseminate the knowledge. We are, but anything beyond will really make it really, in a way, more tangible for the economies. So that's why turning knowledge into technological products will be a key. So that's why this kind of RIC spectrum is very critical and has to be considered in graduate research. I also formulate the welfare cycle for a country. And the prerequisite is going to be really research, innovation, and commercialization. And that brings up technologies. And then, of course, more economic activities, greater prosperity, and the end result is going to be really a better life for everyone. This is very critical. Now, getting a little bit into the today's subject, and also I always pose the question, what people need? People need clean air, clean food, clean water, clean energy. What is really more critical here, this item? If you don't have it clean enough, it will affect water, it will affect your food, it will affect your air. So that's why we have been ended really with some critical issues. Also, making the dimensions of sustainability quickly by considering these 5 E's. Of course, energy is going to be there. Education. The education you get, post-secondary education, is very critical. Very critical, really, you can make difference. And then economy is going to be really part of it. Next, environment. And then more importantly, I bring this ethics into the picture. And many things we see around really not being implementing this specific component. So that's why people think or question sometimes why ethics and where is the social dimension? And I tell them, really this ethics is a shelter. If you develop it nicely, build it nicely, and your social domain is going to be really built nicely. So this is very critical. So that's why I introduce these 5 dimensions for sustainability and making it very critical for a country. In regards to the energy, and I make this point, really the way we care about our personal diet, we should be caring about our energy diet. And we need to change our, by the way, diet from junky food into a healthy diet. Similarly, it's gonna come down to energy and doing something similar. And that's why we need to move out from, let's say, junky fossil fuels into healthy, renewable energy options. Now, I also introduced this clean energy portfolio. This is something very important, and I make it in my own way. And start with exergization. Those who take thermodynamics are familiar with the first law of thermodynamics, second law of thermodynamics. And second law of thermodynamics brings entropy and exergy. So exergy is becoming really a critical tool, and we need to use it properly for system design, analysis, assessment, and improvement studies. Next, greenization. Greenization is essential to really make our existing energy systems more environmentally benign and more sustainable. Next, renewabilization, where we need to incorporate or implement or deploy renewable energy options. And that's why I mentioned a little earlier that we need to change our diet. Hydrogenization, really getting into, and especially what we see, a shift from a hydrocarbon age into hydrogen age. We need to really implement hydrogen energy technologies. Next is going to be really about the system integration. Why integration is critical, and especially for multi-generation, and to be able to design the system for multiple useful outputs rather than a single output. And then next is going to be storagization, where we need to couple really storage technologies to overcome or offset the mismatch between demand and supply. Next is going to be intelligization. We really need to implement artificial intelligence tools, from our machine learning to deep learning, from deep learning to data mining, and really becoming very critical. Oh, even, of course, some may question, where is Internet of Things? Yes, it is also part of it. And making these really essential tools in energy and in achieving clean energy portfolio. This is something I always illustrate, because why? We need to know the history and properly predict the future. Look at here. Humankind started with wood, next by the Industrial Revolution, coal, oil, natural gas. When you look at this carbon-hydrogen ratio going down, and really when you see something coming, and that is hydrogen. And it is really becoming really carbon neutral, or no carbon age, and really addressing hydrogen. Now, in regards to this hydrogen is going to be, of course, used as a fuel, energy carrier, and more importantly, as a feedstock. So when we have hydrogen, clean hydrogen or green hydrogen, and we can synthesize that into many other useful commodities. I will explain later. And I had this article that was published in 2020 when the pandemic had just started. And I made this and saying, really, this COVID-19 coronavirus pandemic has become a kind of turning point, really closing carbon age, but opening hydrogen age. And when you look at it, of course, in 2020, including European countries, North American countries, Far East countries, they declared their strategic plans to develop, of course, green hydrogen technologies and implement them accordingly. Also, when you look at this transportation sector, by the way, these are drawn by my students. And when you look at the transportation sector, what you see, really, the transportation vehicles are crying crying for what? For clean fuels. And if you look at this, of course, the world and what is needed, and of course, you know, from ranging from, let's say, global warming to local climate change issues, from energy issues to sustainability and so on and so forth. And now it is really critical to cure our world. And with what? Hydrogen. Also to illustrate in a way, and life cycle assessment is very critical, folks. Life cycle assessment is in a way, we use it as a potential tool to look at the entire life cycle. So the question, and is it really meaningful to produce hydrogen out of fossil fuels and continue using it? No. No, you see, look at the emissions, so they are not making sense. And what make sense here? Renewables and nuclear. So what is the key here? By using renewable and nuclear energy sources in terms of electricity, heat, etc., to disassociate water into hydrogen and oxygen. That is the key. And in a way, we see renewables have deficiencies. Why? Because of their intermittent nature. Sun is not shining all the time. Wind is not blowing all the time. So what is needed? We need additional players. And what we can have, so we can have hydrogen, for example, and to make them better survive with. Also now what we see worldwide, really great changes. Great changes, and really, of course, in people, economies, and societies. And when you look at these, again, the key is going to be really human capital, which means people. People are more critical. And to train them, educate them, and make them really an excellent asset to the country. And then compared to mines and minerals, of course, human capital will weigh, of course, heavier. And these are very critical. Look at what has been happening around the globe. And Japan has been hosting the energy ministerial meetings, started in 2018, and then 2019, 2020, 2021. And they are continuing this even this year. So one important thing, as declared by Japan, in 2019, they decided to, of course, develop 10 million hydrogen-powered systems in the country and 10,000 hydrogen refueling stations. So it means countries have declared their plans, and really the goals are now clearer. In Canada, of course, we have been doing research and development activities, and also we look at what additionally the other institutions do in the country, and then also, of course, doing time to time an overview to look at these research and development activities, especially coming down to hydrogen and hydrogen energy technologies. And my home university here, as you see, based on the publications, the theses, the patents, and etc. So really leading in Canada. This is very important. So it is really one of our key strategic subject. and making it really, in a way, timely and, of course, as a necessity. I always, in the beginning, I mentioned about innovation. Innovation is very critical, by the way. So any research we do, if it is not innovative enough, forget about it. Forget about it. If something is done already, you don't need to repeat it. Why should we repeat it? Doesn't make sense. Or sometimes what people say, oh, they did it in a country, let's say X, and let's do it here in Turkey. Doesn't make sense. Doesn't make sense. It is very critical, really, to make something innovative. And also, of course, in this particular hydrogen production, I delivered a keynote talk in 2017. And then also, of course, at that time, my PhD student, I asked my PhD student really at that time, I had in my mind 18S concept. And I asked her to really materialize that. And look at here, from safety to stakeholders and strategies, support, sustainability, and so on and so forth, standards, etc. So really making this. And these are very critical, by the way, if we are going to deal with this specific technology. And by the way, you may ask, what about other technologies? Yes, there is a strong need. Some are fully applicable, but not necessarily all are applicable to. So that's why it is necessary to develop such an approach to that particular technology or field. Of course, also making the following. To look at these and then ranking them. At the end of the day, you need to be able to assess the systems. And this is going to be really critical, and you do it in a methodology where you really rationalize your ranking. And we made it between 0 and 1 by considering 18S, and really that way, and studying various technologies. And of course, one is going to be ideal because you want to reach out there. And then accordingly trying to assess them. This is something important. Also, to look at this, this is another project. And I, by the way, I supervise interns and then also, of course, led this project. And this project was aiming to develop a hydrogen hub in Oshawa. Under 3S, I always introduce this energy. If you look at the entire spectrum, really under 3S. Source, system, and service. Source, whatever you do, you need a source. And that's why sources will be, in this particular case, nuclear and renewables. Done deal. Additionally, what is needed here really to produce hydrogen. Hydrogen is a useful commodity and to various sectors. So developing this hydrogen hub, and then also, of course, requiring in this particular case, we have the sources, we target to produce hydrogen, and what is necessary. And what is necessary here, of course, the system. So, and developing these technologies and systems accordingly at the university, and making this hub accordingly sustainable for the economy. If anybody is interested in, of course, we have published, of course, the report is available online, and also, of course, the publication which came out of this study, and of course, in hydrogen energy under various scenarios. And really considering the, of course, Durham region and making it specific to Oshawa, and then really studying this, and this is something which can easily be resembled for various locations and developing such a study. And of course, various scenarios, renewables, also existing grid, nuclear options, and considering the university, and also additionally there is the Pickering and Darlington nuclear stations. These are nuclear power generating stations. And then also, of course, accordingly, having the production methods and transportation options, vehicle types, and of course, refueling stations. So by considering these scenarios, and then also, of course, doing the life cycle assessment, and comprehensively to provide, of course, an assessment. This is very important. Also, I was asked by the government to look at the hydrogen sector development in Canada. This is very interesting to look at this sector development and becoming a critical component for a country. Not necessarily only for Canada, but also for other countries. And of course, production is going to be very important, storage and distribution, and then utilization, and to look at the roadmaps accordingly. Is it really going to be a short, mid, long term? And also to look at the associated challenges. Why? There are many challenges for anything, everything you implement, bringing challenges. And from policies to education, economies to subsidies, safety and other things. So required to be accordingly considered for the assessment. And looking at the options and in terms of production, looking at the utilization in various sectors, very important. So you see, is not really a simple study to look at a sector development unless one does this kind of study to really develop this map. So this has been published in International Journal of Hydrogen Energy just recently. I have also developed this hydrogen farm concept. This is very important. You may think, what is this about? Really, hydrogen farm is about production of green hydrogen. What is required? Renewable energy sources. And then the final product is going to be hydrogen, just like 3S mentioned before. And now what systems to consider? And these are going to be really various types of hydrogen production systems, including electrolysis, thermochemical cycles, photocatalytic, photoelectrochemical, photoelectrolysis, and such processes, and really making this. So calling it hydrogen farm concept. And I have a group in Turkey, in Yıldız Technical University. And really, I asked my group there to really study the entire country, including 81 cities here in Turkey, to really get into every city to look at what renewable energy options are available. And then try to look at and see how much hydrogen can be produced. Only green hydrogen. Look at this. There are top 10 cities identified based on renewable energy sources, including, of course, the biomass. In it, we have also wastes considered. And by the way, you see here, 614.21 million ton per year. This is something after meeting the needs for the country in terms of power and heat. So it means that by using the excess capacities to be able to produce such amounts of hydrogen. And I tell you, 1 kilogram is expected to be by 2030 around, let's say, $2 to $3. Can you see, make little calculation and find how much Turkey can make out of this? And I tell you one quick example. Just 2 weeks ago, Germany signed an agreement with Australia for 5 million tons of hydrogen. And what was that deal about? $50 billion. This is just to give you an idea. And look at this, renewable hydrogen for natural gas, whether or not we produce green hydrogen and then really blend it with the natural gas and then use it accordingly to test household appliances. There was a project in Turkey, and I was the academic lead in that particular project and really developed it and implemented in Konya with Gazbir and Gazmer. So in Konya, and we developed this system and wind and also, as you see, PV panels on the roof, and making this unit accordingly and blending the green hydrogen with natural gas at specific volumetric ratios, and then really trying to investigate the environmental impact and then also combustion performance. So these tests have been completed. In my clean energy research lab, developing various technologies, some jointly with other groups. And this is, for example, copper chlorine cycle. And I have been leading photoelectrochemical hydrogen production methods and developing technologies. As I have my in my lab, really the solar simulator and solarium accordingly to be able to test every reactor and system accordingly. And also, of course, really another project was about scrap aluminiums. And really to look at the aluminum water chemical reactions and to produce hydrogen. And also develop the ammonia fuel cells, first time in the world, making it very unique and also technologically really compatible and tangible. So, and also, of course, developing integrated system by also considering, as you see here, for different communities, by considering United Nations sustainability goals as well. Also, accordingly, developed another technology. I have a large group and then also collaborate with multiple colleagues in my home university. And this was about the sonic hydrogen production method. And this is something mechanical. And of course, there is ultrasonic methods for water treatment. And we developed this technology and later incorporated into this, and to make it in a way that, can we really use wastewaters rather than clean water or fresh water to produce hydrogen? And we have made it, developed this technology, even studied the effect of carbon dioxide addition. What if we really inject CO2 into? Is it really going to help enhance hydrogen production or what? And we studied those. And those are published, by the way. You can find out easily in the literature. I mentioned this 3S approach is very critical: source, system, and service. And in any energy application, you need a source. And of course, the ultimate goal is to produce useful commodities, technically useful outputs, and what is necessary to build an energy system. And the aim, of course, to build it really in an integrated fashion. And that's why now I will quickly make this integration, combination, and achieving multi-generation. Sometimes we hybridize. If you bring two different entities together to make an integrated system or for multi-generational purposes, we rather call it hybridize, bringing something not in the same and from another, let's say, group or another really community. And integration and multi-generation will be very critical. I always show this. This is very interesting. Look at this. In the food sector, and you see, I know some of you drink this, and like my daughters and sons, and 2-in-1, 3-in-1, 5-in-1, 10-in-1. So where are energy engineers or mechanical engineers today and not thinking in a similar way and developing the systems with multiple subsystems and really achieving multi-generation? And why we do that? Because ultimately, of course, we want to achieve sustainability and to make energy systems more sustainable. And of course, this will require greenization. We need to switch from fossil fuels into renewables, and then making it really with multi-generation, and of course, to be able to achieve greenization. This is very important. And we do it in a way by using the same input and, of course, to aim to produce multiple useful outputs. Look over here: power, heat, cooling, hot water, hydrogen, fresh water, drying air, whatever, refrigeration, etc. And with the same input, and of course, what will happen, the increasing the number of outputs will increase the efficiency. And we did experimental works to be able to see what will happen. What if we move from single generation to, let's say, a quadra generation? And you see here, exergy efficiencies accordingly increases. Also developing such systems to look at, this is, by the way, biomass based. And then to look at it here, when we have, let's say, municipal waste, sewage sludge, woody samples, textiles, etc., can we make really a waste to energy system? And then to be able to make it in a way really suitable for communities and generating power, and then also, of course, even having hydrogen, and then also, of course, fresh water, and making it really a biomass-based system, or waste base, and technically these wastes are bio. And also making it in a way, really taking it to the next level. What if we implement the thermochemical cycles by having the, of course, this gasification as part of it, even really coupling it with renewables, and then having electrolyzers as well. Really, this is thermochemical based cycles, and then having these ultimately targeting to produce hydrogen, even blending it with various appliances and testing them. So this was also another system. And also, of course, you see here another biomass-based system targeting to produce hydrogen, cooling, power, fresh water, etc. Really making such systems suitable and depending on what is locally available. This is very important, especially coming down to biomass sources. We need to look at what biomass sources are available around us, and what needs really required, and then accordingly developing such a system. And this particular one, of course, was with the solar field and with gasification, and making it really suitable to produce multiple useful outputs. Another one, really considering these were, of course, specific projects, and I did in the past, and to look at them and to look at the various sources to develop such technologies. And then this is something more recently in our region, and the Durham region in Ontario, to look at this. This was a kind of a local project by the local government, and really they require a kind of roadmap and also a feasibility study to consider the wastes in Ontario, plus use tires, and those are also additional burden. And that's why we looked at this, developed a system for multiple useful outputs, and then, of course, from power to hydrogen, from hydrogen to fresh water, etc., really considering all these accordingly. And then another study. This was, of course, additionally important, and we looked at the various communities. And these are, of course, specifically targeting native Indians, as what so-called Kızılderili toplulukları. And then we have been really as known actually as indigenous communities. And Nunavut is one of the largest territories. And then the aim was, can we develop a feasible community plan where we can have a small modular reactor? And the small modular reactors, these are nuclear, of course, reactors, up to 300 megawatt electricity, and then coupling it with renewables to be able to aim to really consider multiple things, commodities produced, from food to energy, heat to cooling, etc. So managing them that way. Also, to look at this integrated methodology. This is also very important. And we have been developing a sustainability index or integrated sustainability index, and also various sustainability models. And these are, by the way, very, very critical. And these are, of course, when you look at them and developing such models, and even, let's say, methodologies or specific tools require multiple levels of studies. And of course, in here, this was a very interesting study. And Azam Abu Rayash, of course, did it in his PhD, and I supervised him to really develop the Smart City Index. You may think a Smart City Index, and this might be very easy. No, it wasn't easy. I mean, when you look at the word, it may be perceived as something little, but required huge work behind. Why? Because consider 9 groups and 56 really items in total, and then considering every item and collecting the data, and really following this work from framework development, data selection, data processing, normalization, weighting and aggregation, and then doing the ranking and applying to various cities, and also, of course, comparing them accordingly, and really making the necessary assessment. So really huge, huge work, but very interesting. I think at the end of the day, such studies become very meaningful. And I encourage you, really to consider such studies. And yes, now what I have here, and of course, I have my closing remarks. And closing remarks will be this way. Very simple. Sometimes people make really long remarks. No, mine will be very simple. really making it in three legs, and clean energy solutions will be critical, and their management will be necessary, and sustainability is going to be the goal to achieve. So these are, and then having said that, and I really want to make one quick announcement. I know some of you may know I am chairing the world's, of course, hydrogen energy conference, and in Istanbul, which is going to start on the 26th, and something very important. And now I like to stop here and entertain any questions you have got for me.
Thank you, dear professor. It was an honor for us having you in our symposium. So we have time for questions.
Yes.
Yeah, so if you raise your hands, we can unmute you and ask your questions if you like. I guess it was all clear, Professor.
Presumably, and so I will be traveling. So, and I wish you a great success with the conference and all the best. And keep in touch then.
Thank you very much. Have a good travel.
Thank you. All the best. Bye bye.
Bye bye. Dear participants, we will have a break between 12 and 12:30. After the break, our symposium, which will continue as 9 simultaneous sessions, we will start at 12:30. You can find the links and timeline of the sessions on the symposium's website, igrs.itu.edu.tr. You can find the link on the chat board too. We wish you a nice day with science.